Assalamualaikum warahmatullahi wabarakatuh. Today we will present our mini project for ECE354. Our mini project title is Home Appliance Controller. Before we start our presentation, I will introduce my name and my group mate. My name is Muhammad Aiman Azikim bin Saifullah Noor, and my group mate is Dinesh Iman bin Sharifuddin with Muhammad Dinesh Hakim bin Noor Azam. For introduction, the ECE project is a system made to effectively control home appliance. It is controlled by the IP switch and LCD to provide real-time updates and LED indicator to reveal the status of the appliance. This technology enhances accessibility, convenience and energy efficiency, contributing to more intelligent and effective home management.
Okay, now we go into our circuit design. So for this project, we use three components, which is dip switch, LED, and LCD. And then for the connection, we use three port, which is port H, port B, and port K. For port H is configured as input to read dip switch. For port B, configured as output to control LED, and for the last port is which is port K, configured as output to control the LCD. So this is our schematic diagram. We have four schematic diagram, which is schematic diagram for dip switch, schematic diagram for LCD display, schematic diagram for LED, and the last one schematic for SCS12 Dragon board.
Okay, Assalamualaikum. I'll explain to you about the coding for our project. A bit program overview. The code controls the system of appliance by using the IP switch and display the status on an LCD, and also use LED as an indicator for which switches are turned on. So the first part of the coding, as you can see at the left side of the screen, we define our port K, which is the LCD to be used, and then we set the program to start at the address $2000, and we configure our input and output ports, which is port H is for input, port B for output to control device, and port P and port J to used as a control signal. Okay, so our main loop. The first main loop, the system will initialize the LCD display by using the code open LCD and shows the message system is on. For the next part of the loop is putar. This part is about switch input detection. The programs will check the state of switch connected to port H. If a switch is pressed, it will detect by comparing the input with specific binary values. For an example, switch 1 is 00000001, and switch 2, switch 3, switch 4 is the binary value for them respectively. So for each switch, the corresponding device is turned on by setting the appropriate output on port B. So example, switch 1 is it will activate the lamp, switch 2 it will activate the fan, switch 3 it will activate the TV, and switch 4 will activate the aircon. So moving to the subroutine, I give you one example, which is the subroutine lamp. When the switch turn on, the LCD will display a message which is lamp is working, and a delay is added to ensure that the code runs smoothly. And I forgot to mention that An LED also will be turned on when with the corresponding switch. So same goes to the subroutine fan, TV and AC. After the device message is displayed, the system will return to the main loop, awaiting for the next switch is pressed. But be minded that only one switch can be turned on at a time. So for the short explanation, the program starts by displaying the system message and check if any switch is pressed. If one switch is pressed at a time, the corresponding device is activated and the message is shown on the LCD, and the system will continue to loop and waiting for the next input.
This is the flowchart for our project. So the system starts by initializing the LCD message, which is the LCD will display the message system is on for 3 seconds. We move to the first condition. For the first condition, if the switch 1 is turned on and if it's yes, the LED 1 will activate and updates the LCD to display the lamp is working for 5 seconds. If it's no, we move to the second condition. For the second condition, if the switch 2 is turned on and if it's yes, the LED 2 will activate and updates the LCD to display fan is working for 5 seconds. If it's no, we move to the third condition. For the third condition, if the switch 3 is turned on and if it's yes, the LED 3 will turn on and updates the LCD to display TV is working for 5 seconds. And if it's no, we move to the last condition, which is if switch 4 is turned on and if it's yes, the LED 4 will activate and updates the LCD to display AC is working for 5 seconds. If all the conditions didn't met, for an example, no switches is turned on, or all the four switches is turned on, the system simply loops back to the start, displaying system is on again. This is for the result. So after we connect the HCS12 Dragon board to the computer, the LCD will display the system is on. After that, after we switch on the first switch, the first LED will turn on and the LCD will display the lamp is working. If we switch on the second switch, the second LED will turn on and the LCD will display the fan is working. If we turn on the third switch, the third LED will turn on and the LCD will display the TV is working. And the last one, if we turn on the last switch, the fourth LED will turn on and the LCD will display the AC is working. But if we turn on all the 4 switch, the LCD will display the system is on and the LED and none of the LED will turn on.
Moving on to our discussion of the project, a bit system overview. We successfully demonstrate the capability of the HCS12 microcontroller to manage multiple devices using input switches and LCD display and LED output ports. Secondly, we use lower bits of port H for input switches and use port P for device control to separate input and outputs. Next, we got our challenge and solution throughout the making of this project. So the first challenge we met is the switch bounce issue. The switch bounce is when a mechanical switch is pressed or released, its contacts bounce momentarily, causing multiple rapid on-off switch signals. So to To resolve these problems, we use a delay routine to prevent incorrect multiple inputs. By adding delay routine in code, it effectively filter out these unwanted bounds. Second is hardware integration. So to ensure all the components of HCS12 microcontroller, LCD switches and output ports working together without any communication issues, we need to always troubleshoot the coding so that it will work as we wanted.
For innovation, first, to develop a microcontroller-based control system using the HCS12 microcontroller to manage multiple devices such as lamp, fans, and room system. Second, to implement an interactive feedback mechanism using an LCD display to provide real-time status update of the control devices. Third, to implement an interactive feedback mechanism using an LCD display to provide real-time status update of the control devices. For the conclusion, the SSC project successfully demonstrates a simple and efficient approach to managing household appliances. By integrating user-friendly controls through a DIP switch, visual indicator with LED, and real-time status updates on a LCD, the system enhances convenience and accessibility. Furthermore, it promotes energy efficiency by providing clear feedback on employee usage. This project highlights the potential for affordable and practical solutions to contribute to smarter and more sustainable home environments.